In 6.2, we're going to be working with something called the law of sines. Here we're going to be solving triangles, but we're going to be solving oblique triangles. And an oblique triangle is just one that is not a right triangle. So it could be an obtuse triangle, meaning that one of the angles is an obtuse angle, or it could be an acute triangle, meaning that all three angles are acute, but no right angles at all. Okay. Now, the law of sines holds even if I have a right triangle. So it would work if one of my angles was 90 degrees, but if one of my angles is 90 degrees, it's much easier to just use Pythagoras and the definition of my trig functions. Okay. What the law of sines says is that this ratio, and we're using the same convention, that we're naming the sides using the lowercase letter of the name of the angle, which is a capital letter. Okay. So the ratio of the sine of an angle over the side that's opposite that angle is the same for all three of my angles. And here it does not matter whether I put sine of the angle on top and the side length on bottom or vice versa, as long as I'm consistent. So if these three fractions are equal, their reciprocals are equal as well. Okay. Now, we can use law of sines essentially anytime we know an angle and the side opposite it, so that I've got a complete one of one of these fractions. And then if I know a side length, I can use that to find the angle, and vice versa. There are two times when that's going to give us unique answers. If I have angle, angle, side. Okay. And the way I'm labeling this, angle, angle, side, would mean I have this angle, and then the following side. So that would be angle A, angle B, side A. So as I sort of just work my way around the triangle. Or side, or angle, side, angle. So I've had angle A, side C, angle B. That would be an example of angle, side, angle. Now the other way that I could have one side and one angle that are opposite each other would be if I had angle, side, side. So I've had angle A, side C, and side A. Now that often leads to what we call the ambiguous case of the law of sines. Okay? That can happen because if I know the sine of an angle, that's not enough for me to know whether that angle is acute or obtuse. And sometimes when this is the information that I have, an angle and then two sides, if that's the information I have, sometimes both an obtuse angle and an acute angle with the same side would work. Sometimes only one of them works, sometimes none of them work. So that leads to the ambiguous case. I'm actually going to skip that this semester just in the interest of time. So it's included in your text in section 6.2, but I didn't assign any homework problems from the ambiguous case, and I won't put that on exams and quizzes. Okay. The way I remember that that's the ambiguous one is that it's kind of the one that's a pain in the butt. Okay. All right, but if I have this information, and you'll notice that with both of these I know two of the three angles, so that's going to determine what the third angle is. So I won't have any ambiguity of, I know the sine of the angle, but how do I know whether it's obtuse or acute? I'm going to know all of my angles. Okay. All right, so let's just try one. Let's suppose that I know angle A is 33.1 degrees, angle B is 24.2 degrees, and side A is 3.5 centimeters. Okay. So let's see if we can't solve that triangle together. And I'm going to round everything to the 10th place. So I gave everything to the 10th place, and we'll round everything to the 10th place. All right, so I like to start with a picture. Let's see. I can actually kind of tell. This is A and this is B, 33.1 degrees and 24.2 degrees. The two of those together add up to less than 90, so my third angle is going to be obtuse. Now, I'm not worrying about drawing this perfectly to scale. If I were to get out a protractor and measure my angles, I'm sure they'd be inaccurate. But I can tell that this is going to be obtuse, so I might as well draw it as an obtuse angle. Okay, let's go ahead and get side C, or angle C first. So 33.1 and 24.2 degrees, that's going to add up to 57.3 degrees. Okay. Adding C to that, I'm supposed to get 180 degrees. So to get C, I'm going to just take 180 and subtract 57.3. So C is going to be 122.7 degrees. Okay, excellent. Now I was given side A, that was 3.5 centimeters. So now I'm just going to use law of sines to try to get sides B over here and C over here. And remember, in general, I try to avoid using calculated values, but the exception is with the angle. There's no problem with me using an angle that I've calculated because the relationship between my angles is an additive relationship. Okay, so I'm able to say that sine of 33.1 degrees over 3.5, let's go ahead and find B first. That's going to be sine of 24.2 degrees over B. Okay. All right, so if I cross multiply, B times sine of 33.1 degrees is equal to 3.5 times sine of 24.2 degrees. To solve for B, I'm just going to divide by sine of 33.1. So B is 3.5 times sine of 24.2 degrees over sine of 33.1 degrees. And at this point, I want my calculator. Okay. Now, I'm pretty sure that I'm in degree mode. I don't think I've changed it, but I'm going to just double check. So I'm going to plug in sine of 90. I got 1. If I were in radians, sine of 90 radians is not 1. Okay, so let's see. 3.5 times sine of 24.2 divided by sine of 33.1. Okay, and I get 2.627 blah, blah, blah. We said we were going to round to the tenths place. So since that's smaller than 5, we would round down. So this would be about 2.6. So I'm going to say that B is approximately 2.6. And that would be centimeters, because those would be the units I'd be using for all of my lengths. Excellent. So now I want to get C. So I'm going to use law of sines again. But now my second ratio is going to involve angle C and side C. So sine of 33.1 degrees over 3.5, that part stays the same. That's sine of 122.7 degrees over C. And again, we cross multiply. So C times sine of 33.1 degrees is 3.5 times sine of 122.7. C is going to be 3.5 times sine of 122.7 degrees over sine of 33.1 degrees. And we pull out the calculator. Now, because calculators really are needed to take things any further, if I were to put this on a proctored exam or quiz, I would just ask you to leave it at this point. Get it to the point where you're ready to plug into a calculator. On a take-home exam or quiz, on a take-home quiz, I would expect you to use a calculator, and I would say so explicitly in the directions. And I did something weird because I just got a negative number, and that's not possible. So 3.5 times sine of 122.7. I think I just forgot to close the parentheses after that. Okay, So now I've done that. Divided by sine of 33.1, close parentheses. Much better. So I'm getting 5.393 blah, blah, blah. We're rounding to that place. That's going to round to 5.4. And that would be 5.4 centimeters. One thing you can do that's a nice, quick, easy check. Notice B was the smallest angle, so side B should be the shortest side, and it is. C was the biggest angle, so side C should be the biggest side, and it is. If you violate that rule, you've made a mistake somewhere in your calculation.